All right, everybody. The quiz on Friday is going to be on chapters 1 and 2. Therefore, I want to go back and do post some videos on some of the suggested problems on the course directory, and this is one of them. 242 is example, a very general physics problem where you drop something from some height, and sometimes they ask you the time it takes to drop down, sometimes they ask you the velocity which is the ground, sometimes they'll ask you what is the height of the building, and so on. So this type of problem, and any other problem, it helps to first draw what's going on. The brick is dropped from some height y1 that is unknown, with an initial velocity of 0. It strikes the ground at y2 equals 0, 1.9 seconds later, and the question asks, what is the height of the building? All right, so first you have to recognize what type of exercise it is, and realize it is a kinematics exercise, because I'm going to be using acceleration, distance, times, and so on. For practice, you know that the body diagram of this brick should only have one force going down, therefore negative mg, the sum of the forces, is equal to may. It gives you the result you already know, that is acceleration in the y is negative 9.8 meters per second squared. Since this is a constant acceleration, you can use the kinematic equations, which we'll give to you in the quiz, and they're the following. So remember, this will give the quiz to you. They might give it to you in terms of x, but you know that it also works for y. Okay, so in this problem, then you recognize, well, sorry, maybe that again. You want to see which equations you can use. Well, you see that you already have the y2, you have the initial velocity, and of course you have the time, and the acceleration, of course. So you can use that first equation to solve this problem. You get that 0 minus y1 is equal to 0 plus negative 9.8 meters per second squared. That's 1.9 seconds squared over 2. So for y1, you should get 17.7 meters. The next question is, what is the magnitude of the brick's velocity just before it reaches the ground? So to do that, I know that I have the initial velocity v1, I have the ay, and I have the t. So I can solve for v2 and get this is 0 plus negative 9.8 meters per second squared times 1.9 seconds, and get the v2 is equal to approximately 19 meters per second, and it should be negative. All right, the next question is to sketch the acceleration versus time, the velocity versus time, and the y versus time. So one way you can do this is the following. The acceleration. I know acceleration is negative, and it is constant, so it should look like a straight line for my ay versus t. So you know the integral of a horizontal line that's not zero would be a slope. And since it's a negative slope, then I should get for my velocity a downward slope. Since I start from a velocity of 0 that gets more and more negative, then my velocity should look something like this for my Vy versus t graph. If I get the integral of that line, then I should get a parabola for the y. I start from some initial y of 17.7 meters, so my first point should be somewhere here. Also, my slope here should be 0, since I'm starting with a velocity of 0. And then the parabola should start coming out, so that about 1.9 seconds, that parabola is such that y2 equals 0. And that's it. So once again, the acceleration is constant, the velocity decreases linearly, and it starts from 0. Your parabola starts from 17.7 meters, and it's important you remember that this slope here should be 0. All right, I hope that's useful. What happened? It didn't save it.